Hello everyone. What we'd like to do in this video here is examine how we could change the period of a sine and cosine graph. For sine and cosine, here's a graph of sine, the period of sine and cosine is 2 pi because this is the shortest distance on the x-axis I can have before the graph just starts repeating itself. So what I want to know here is what could I do to this type of function to actually change the period? Essentially, I want to think about, can I vertically compress this graph? Can I vertically stretch this graph? And how could I do that? Well, if I'm thinking about how to vertically, I don't know, at least stretch or compress it, since I would be changing the x values, I would think I should be directly affecting the inputs of the function, or I should be doing something directly to the x values. So let's examine what happens if I multiply, instead of an x, what if I have a 2x inside of sine? What if I multiply the x value by 2? Or what if I have a 1/2 x inside of sine rather than x? Or if I multiply the x value by 1/2? Now let's think about what these graphs would look like. Is this going to be something that's going to be more stretched? Is it going to be more compressed? Well, let's think about it. So to get to 2 pi, and when I plug in 2 pi, I get an output of 0. I have to replace x with 2 pi. But how far do I actually have to go out on the x-axis to get this same output? Well, since I'm multiplying, or since the inside of this function is 2 times x, I don't have to plug in all x as a value of 2 pi to get there. I only need to plug in an x value of pi to get there. Here, I have to plug in 2 pi to get here. But since it's 2 times x, now I only have to plug in pi. So now if I plug in pi, it takes me less to get to the end of my period than here. So now I only have to plug in pi to get to this output. So I should be right here. Similarly, what do I have to plug in? What do I have to plug in to get this output of 0? Over here I have to plug in pi to get an output of 0. What x value would I have to plug in to have the inside be pi? Well, I'd have to plug in pi over 2. Since 2 times pi over 2, the 2's would cancel, I'd get out pi. So this would now be pi over 2. So what's going to be happening here is I'll still have those 4 corners, but the graph is being compressed by a factor of 2. So this new graph here, so 1 pi over 4, 2 pi over 4, 3 pi's over 4. The graph here will be compressed. So when I multiply the inside, if I multiply the x value by a number bigger than 1, what that's going to do is that's going to compress my graph. Similarly, if I multiply the inside of my function by a 1/2 times x, what value of x would I have to plug in to get to 2 pi? Well, what times 1x, what value times 1/2 gives me out 2 pi? I have to replace x with 4 pi. I gotta plug in a bigger x value, so the inside is 2 pi. I gotta plug in 4 pi. If I take 4 pi and I multiply it by a half, I'll get out 2 pi. It'll be this output. So in this case, when I'm multiplying the inside of the function by a half, I'm actually stretching my graph out. Notice plugging in 2 pi into here, I do 1/2 times 2 pi. That'd be evaluating sine at pi. Well, sine of pi is 0. So what we're going to have here is when I multiply the x value by a fraction, this actually stretches my graph, because I have to plug in a larger x value to get the same outputs. So 1 pi, this is 3 pi. So what we have here is a sine graph with a much larger period. Okay. So for this one has a period of pi. For this one here, for the original sine graph, it had a period of 2 pi. Over here, this graph, this has a period of 4 pi. So this value that I multiply onto the x value changes my period. If I multiply the x value by a number bigger than 1, this compresses my graph so I have a shorter period. Because I have to plug in a lesser value of x to get the same outputs. Over here, if I multiply the inside of function by a half or by a fraction, I have to plug in bigger values of x to get the same output. So it's going to horizontally stretch my graph. It's going to increase my period. So there is going to be a nice quick way in general that we can actually figure out what the period of a graph is without doing these type of exercises. So this is how I think about the periods. So instead of drawing pictures, I think about it in terms of intervals, and then we'll do it in general. Is there a general way to find the period just by looking at the graph? Well, let's think about first sine of x. Let's do sine of 2x. Let's do sine of 1/2 x. And let's do it in general. What if it was sine of any number times x? It's very common that the book calls this omega x. So it's the value multiplied in front of the x. This is called omega. Okay, so what would be true here? Well, the x value for one period, so one period, the x value is going to be between 0 and 2 pi. Over here, the inside of the function, well, one period, the inside would have to be between 0 and 2 pi. I'm going to make this table. So I'm going to have one period when the inside of the function, I'm plugging in values between 0 and 2 pi. Over here, when the inside of the function is between 0 and 2 pi. Over here, when the inside of the function is between 0 and 2 pi. So when I'm talking about the periods, I want to know the x value. I want to know what the x value is in between. I want to know what 2x has to be between. I don't want to know what 1/2 x has to be between. I don't want to know what omega x has to be between. I can easily solve all of these to figure out what the period would be. For this one, we'll just divide everything by 2. We're basically solving for x here. So I need 2x to be between 0 and 2 pi, so that means x would have to be between 0 and pi, and that's what we discovered the period was. Over here, instead of dividing everything by 2, how would I multiply everything by 2? So I'm going to have that x is going to be between 0 and 4 pi. So the period is 4 pi. Now in general, whatever number is right here, how do I figure out in general what the period is? Well, here, how about we divide everything by omega? Okay, so I would have that x would have to be between 0 and 2 pi over omega. So in general, the period is 2 pi divided by omega. Now, this is something that's easy to forget. What I always do is if I want to think about how am I going to get one period, whatever's on the inside of the function between 0 and 2 pi, and then I'll solve for that x value if you forget this. So this is the general formula for the period of graph when I multiply the inside of a function by a value, in general omega. You're going to take 2 pi, you're going to divide it by omega, and that is going to give you the period. Okay, let's do some examples of graphing. Okay. Do a few examples. So let's go ahead and graph. How about f of x, which is equal to, how about -3 times sine of 4x? Okay, go ahead and pause the video and see if you can do this one here on your own. Okay, let's do it. Now, just like in the last video, the main things I'm usually going to be paying attention to from the beginning is where the equilibrium is and where the amplitude is. Okay, well, first of all, notice I'm not adding anything to my function, so I still I still have an equilibrium at 0. Notice I'm multiplying the outside of my function by 3, so I know by -3, the negative will correspond to a reflection. So the amplitude here is going to be 3. So I'll go 3 units up from the equilibrium, and 3 units down from the equilibrium. So I know that my graph lives in this window. Okay, now I just need to figure out how to appropriately label the x-axis here. Well, I need to figure out what the period is. So if you forget, what I need to make sure of is I want to know when the inside of sine is between 0 and 2 pi. You could divide everything by 4 to solve for x. So that means that x would be between 0 and 2 pi divided by 4 will be pi over 2. So here we actually have that the period is pi over 2, or if you did 2 pi over omega, omega here would be 4. 2 pi over omega would give you the pi over 2. Okay, so now I'm just going to mark those on my axes, or on the x-axis. So what I'll do is maybe I'll put a pi over 2 here. Now how I label these, I just want to at least have 4 notches on the x-axis. I'm going to take this pi over 2 value, and then I'm going to cut it in half. Half of pi over 2, if I take pi over 2, dividing by 2 is the same as multiplying by a half. So if I cut that number in half, I'm now at pi over 4. So I'm at pi over 4. Think about if you have a pizza, you take half of it and then another half, you should be left with a fourth. So I'll cut this in half. I'll cut it in half again. So if I cut that in half again, I'll have pi over 8. I have 1 pi over 8, 2 pi's over 8, I have 3 pi over 8. So I've marked these 4 spots. And now I'm just going to bounce appropriately. Okay, so let's see here. Sine always starts at equilibrium. Sine would normally then go up, but I'm reflecting the graph over the x-axis, so I'll start here and then I'll go down. And there we have it. Connect the dots. And here we have the graph of -3 sine of 4x. Beautiful. Okay, let's do another example. Okay, let's do, how about f of x? F of x is equal to, okay, how about -5 cosine of 1/3 x? How about -2? Okay, go ahead and pause the video and give this one here a shot. Okay, let's do it. So, again, the main things I'm going to pay attention to here are where the equilibrium is and what the amplitude is. I'm shifting this graph down by 2 units, so I know the equilibrium is at -2. And my amplitude will be 5. So 1, 2, 3, 4, 5. I need to go 5 units up from the equilibrium. So what will this be? 3. I need to go 5 units down from the equilibrium. 1, 2, 3, 4, 5. So with -3, -4, -5, -6, -7. Okay. I'll mark the upper and lower parts of my amplitude. Okay, so I know that my graph is going to live in this window. Now I just got to figure out how appropriately it bounces. I need to make sure, first of all, to label the x-axis appropriately. So I need to think about the period. Well, you could do 2 pi divided by 1/3, or I'd just like to think about, okay, I need the inside of the function to be between 0 and 2 pi. Okay, if I multiply everything by 3, I'm going to get that x is between 0 and 6 pi, or we have that the period is 6 pi. Okay, so let's write that. So let's write 6 pi. Okay, let's cut that in half. So I'll be at 3 pi. Let's cut that in half again. So what we're going to get 3 pi over 2. So we have 1 3 pi over 2, 2 3 pi over 2, 3 pies over 2. So what are we going to get there? 9 pi over 2. So we'll get 9 pi over 2. Okay. So now we will figure out how to bounce off of these. So cosine, let's see, cosine will normally start at the upper part of the equilibrium, but it's now going to start at the lower part of the equilibrium because I'm reflecting it. So I'm going to start here, and we're going to go ahead and bounce around these spots. Here, we have a rough sketch of -5 cosine of 1/3 x minus 2. I hope you enjoyed this video. In the next video, what we're going to do is we're going to learn how to shift the graph left and right. And that'll be the last transformation we'll do with sine and cosine, and then we'll start focusing on the other 4 trig functions and their graphs. We'll see you there. Take care.